Good day, everyone. Today, I would like to put you through on how to use this QC takeoffs template. The essence of this template is for quick measurements, in short, for time management in terms of taking off our quantities. So, without wasting much of our time, let me put you through on this drawing. We are going to work on two drawings because the plugin is designed in such a way that to be useful for maybe you are taking off for raft foundation, strip foundation, and finishes. The only thing that's yet to be included in the template is pile foundation, which is going to be considered during the second version of this template. So first of all, we have strip foundation drawing and raft foundation drawing. So let me first of all introduce you to this strip and pad foundation. So this is the strip and pad foundation. So what's the depth of the foundation? Let's take the depth of the foundation. The depth of the foundation, you can see this is the existing ground level. So the depth of the foundation is 550, meaning 0.55. So how are we going to do this? We are to take off for this strip and pad foundation by using QC templates. So the template has been created. So let me show you the templates. Under this template, I click on this template. So this is the plugin, QC plugins takeoff is here. Has been created for you. So their group based on the level of work. You have substructural elements, you have superstructural element, and staircase. What are the items under substructural elements? You have strip and pad foundation, raft foundation. So under strip and pad foundation, there's other items that we are required to take off for under substructural element. So let me go back to start using this plugin for our measurements. So first of all, I will click on this substructural elements. And we are to do going by using normal tool on Planswift. I'll first of all click on this tool, but no. I will click on having shown the QC plugin. So I will click on this substructure. So it brings strip and pad foundation. Since I'm to work on strip and pad foundation, so I will click on this strip and pad foundation. So it means site clearance excavation. So the first item we are to take off for under this section is excavation. So I'll click on this green ball in front of this excavation. I'll click on it. So it brings excavation. So what type of excavation do I want to take off for? So let's start with trench excavation. So I put trench excavation. So as I saw earlier, the width of our trench is 0.68. 0.68. And the depth, as I showed you earlier on, is 0.55. That's the depth of our foundation. So having inputted all these variables, we'll click on OK. So now we'll start taking off these trenches one by one. So it seems I've considered all the trenches. So you see the magic of this template, this quantity takeoff templates. So having done this, so I will now click on this takeoff summary to see all the sub items. So you can see that I took up for trench excavation all other items, all other independent items that have been, their quantities have been generated, like earthwork supports. These quantities have been generated, backfilling, level and compact, blinding to trenches, concrete and foundation. So we have to include what's the thickness of concrete foundation. So let us check what's the thickness of concrete in foundation. So we have to check what's the thickness of concrete foundation. So let me scale it. Okay, it's 150. So I will double click on this concrete foundation and input the thickness. It is 0.15 and click OK. So the concrete foundation has been generated. What of block wall and foundation? So we have to check to know the height of block wall in foundation. So I have to scale to know the height. So you have to check the height of the block wall in foundation. So the height of our block wall in foundation is 0.75. So I'll go back to takeoff summary. So you put double click on this block wall foundation and you put this at 0.75. So the quantities have been generated. You see the uniqueness of this quantity of templates. It's unique in such a way that once you take off one item, like 6 items will be generated. The quantities for 6 items will be generated. But currently, I took off for trend excavation. I got my quantities for support to pieces of excavation, backfilling, level and compact, blinding to trenches, concrete in foundation, and block wall in foundation. All these quantities have been generated. So the next item to look at is, let me go back to bookmark. So the next item to look at is columns, concrete column, by using this QC quantity takeoff templates. So let me go and look at the column section. Okay, before going to column, let us take off for our pad, concrete base. So concrete base. So I'll click on this excavation to concrete base. I'll click on this. So we have base type 1, base type 2, base type 3. We have base type 4 and base type 5. So for the sake of this tutorial, I will consider base type 1. So what's the size of this base type 1? We have it 1.2 by 1.2. 1.2 by 1.2. So let me go to the plan. Here's the plan. Okay. Let me up this. So base type 1. I will click on this excavator to concrete base. Since I'm to consider only this type 1, so pit excavation for column base type 1. So what's the depth of a column base type 1? So let me check. What's the depth of our column. So this is the depth, 900 plus 350 plus 50 equal to 1.3. So that's the overall depth of our pit excavation for column basis. So let me click this once again. So pit excavation for column base type 1. So what's the depth of our trenches? So number of column base, we are yet to know the number, so I will just put 1 there. So the longer side, that is one side of the column base, we have it 1.2, and the other side we have it 1.2 also, and the depth, as I shown earlier, we have 1.3. Depth of our column base pit excavation is 1.3. So having inputted all these parameters, I'll just click on OK. So I'll be clicking on column base type 1. This is column base type 1. 1, 2, 3, 4, 5, 5. Since that's all for column base type 1, we have it in 5 places in this plan. So having consider all the column base type 1, so I will just click on this red button or click on this digital record to drop this tool. So I will drop the tool. So let me go to take off summary to look at the sub items under this pit excavation. So you can see now these quantities for my pit excavation for column base type 1, 9.36. So quantities for concrete column base is yet to be generated because I have not included the variables for this. So I will double click on this concrete column. So what's the thickness of the concrete column base type 1? So let's check together. So let me, what is the thickness of the column base? Column base. So you can see it's 350 and the blind is 50. So it's 350 and the blinding is 50. So let me go back to the summary. So I will double click on this to include the thickness, which is 0.35. So the quantity for concrete column base type has been generated. What of formwork? I will double click on formwork 2. So number of column base, we have it in 5 places and the thickness is 0.35. 0.35. Click OK. So what of reinforcements? So of reinforcements. So I will double click on this reinforcements. So let's consider the main bars they use for this column base type 1 is Y12, space at 150 mm. So Y12 for column base type 1. So number of column base, we have it in 5 places. So what's the diameter of Y12? The weight is 0.88. So the spacing for this main bar is 150 mm. So 0.15. So side A, I named this side to be side A. So side A is 1.2. Side B also, the other side is also 1.2. So vertical bend, we all know that it's the bend, we have to know the bend, and we know the thickness of the concrete base is 350. And let's deduct 50 from 350. So we are left with 300 one side and 300 the other side. So vertical bend is going to be 0.3, and its number of vertical bend we have in 2 places. So the cover, let's assume to be 0.05. Number cover side we have in two sides. So we have inputted all these variables and click OK. We just look like this. So it has quantities for our Y12 has been generated to be 136.16 kg. So what of, so that's it for column base. So at a single click for pit excavation for column base type 1, we've gotten our concrete for column base, formwork to column base, reinforcement to column base. So the next item to be considered under this strip apart foundation. Under this strip and part foundation is our column. So our column. So click on this column. So we have 2 types of column that has been designed here. We have rectangular column and we have circular column. So since we don't have any circular column on this plan, so I will consider this rectangular one. I will click on this rectangular one like this. So it brings this. So we have different types of column. We have column type 1, column type 2, column type 2A. So for the sake of this lecture, we'll consider only column type 1. So concrete column type 1. So what is the total number of column type 1 that's been stated there to be 2 numbers? So we put the 2. So what is the thickness? What is the thickness of this column? Let me. So we have the size of the column is 450 by 230. 450 by 230. Concrete column type 1. So it's in 2 places, and the thickness, you know that thickness is 230, 0.23, and the width 0.45. So click OK. So the height of our column is from here to here. So the quantity for our concrete column has been generated to be 0.6 cubic meter. So let me click on this takeoff summary to see the sub items. So we have to we put our variables for reinforcement for us to get the quantity for reinforcement. So I'll double click on this reinforcement. So what's the diameter of Y12 they use? What's the diameter of reinforcement they use? Let me bold it. So you can all see now. They use 1, 2, 3, 4, 5, 6, 7, 8. 8 number of Y25 to be members of this. So diameter is 25 mm. The weight of 25 mm, if you convert to weight, so is 3.85. So number of column is 2 number. So number of straight bar, you have it in 8 places. So there's going to be projection. There's projection that will link ground floor column with first floor column. So the projection, let's assume the projection is 0.40. So and it used to have bend too. So let's assume the bend is 0.3. So we have inputted all these variables and click OK. So the quantities for Y25 has been generated to be 232.23. So what of the link? Our link Y10 space and 175. So for our link, I will double click on this and input all the variables. So number of column is 2. So the diameter is 10 mm. The bar width is 0.616. So the spacing for Y10 is 175. That is 0.175. So number of side B, we have 2 sides. Number of side A, we have it 2 places. So side B, meaning side B, I named this side to be side B. So we have it 1, 2. That's why I inputted 2. Side A, I named this side to be side A, 1, 2. That's why I inputted 2. So side B, we have 0.45 to be side B. So side A, we have it to 0.23. 0.23. So hook, let's assume our hook is 0.15. So cover, let's assume 0.025. So side of cover, 2 places, and click OK. So the quantity for Y10 has been generated as well to be 28.44 to be 28.44 to be 28.44 kg. So what of formwork? So I will double click on this formwork. So number of column is 2. So click OK. So quantity for our formwork has been generated as well. So quantity for has been generated as well to be 5.6 5. So the next item to consider under this strip and pad foundation. So the next item to consider under this strip and pad foundation, let me go back to look at. So we have considered. So let's consider staircase. So if you look at this staircase, this plan, if you look at it, it's a semi-detached building. We have staircase on one side and staircase on the other side of similar type. So we have one here, it's a U-shaped staircase. So let me go to the plan to look at the section, section of the staircase. Section of the staircase. Yes, this is the section of the staircase. So this section is showing this one is showing this one, and this one is showing this one. So for the sake of this class, I will only consider this one. So you know this one, we have it in two places, one side and the other side, and the number of floors we have is 2, from ground floor to fourth floor. So if you want to take off our staircase template has been created as well. So I'll click on this staircase. So concrete staircase. So first of all, we have to scale. So we know that our riser is 150 and our step is 300. So let us know the length of this waist by dimensioning it. So length of the waist is 2.45. What of length of our landing? Length of our landing is 1.24. So let's know the width of our landing. If you know the length of our landing, what of the width? The width. So the width is 1.1. So I now click on this concrete staircase. So floor number, we have floor number, we have it to be to ground and top floor. But don't forget that this design is a semi-detached building. So we have staircase on one side and a staircase on the other side, making it 2 widths, and they are in 2 floors, making it 4. 2 sides of staircase and 2 number of floors. So we have to make it 4. And landing length, what's the length of our landing as we scale here is 1.24. So 1.24. The width of our landing is 1.1. It's 1.1. It's 1.1. And the thickness is 0.15. So that's for landings. What of the waist? So I will click on this waist. So what's the length of our waist? We have it to be 2.45. 2.45. What's the width of our waist? Is 150 mm. 0.15. Sorry, width of our width of our waist. So the width of our waist is going to be equal to the length of our landing, which is 1.24. 1.24, and the thickness is 0.15. So what of step and riser? Complete for step and riser. So what's the total number of our step? We have them in 6 places. So 1, 2, 3, 4, 5, 6. So 6 number. Step length. What's the length of our step? Our step is 0.30. Sorry, step length. The length, that is the length, the length of our landing. equal to the length of our step. So it's 1.24. So our riser is 0.15 and our step is 0.3. So just click OK, click like this. So the total quantity for this concrete is 3.3 cubic meter for this section of staircase. We only consider this section. We have 3 sections. We have 1, 2, 3. So let's click on takeoffs summary to see the sub items. So all the quantities for our staircase has been generated. Concrete 3.31 cubic meter. So for the formwork, to our staircase, so I will click on this. So formwork to staircase. So we input all these parameters. Number of floor we have in 2 places and staircase in 2 places, making 4. So length of a landing, we have it to be 1.24. Landing width 1.1. So our waist width, we have it 1.24. Length of our waist 2.45. Okay, dots. So the total square area of for formwork to this landing for this staircase 16.24. But if you want to calculate for a reinforcement to staircase, so there's no shortcut for that other than to measure it in a conventional way, the way we used to measure by using these tools to measure for our reinforcement. So that's that for our landing. So the next item to look at is grand beam. So our grand beam, let's just look at grand beam. So, yes, so this is our grand beam. It's 450 by 230 grand beam. And you know that whenever they want to cast, they will not cast the grand beam full. They will have to leave 150 mm for slab. So if our height of our grand beam is 450 concrete, so we have to less 150 thickness of our slab. So the balance is going to be 300 mm. So that is the thickness of our grand beam is 300 mm. And once again, before we start measuring, you have to confirm the length of this short reinforcement. So the lapping now, you have the lapping in 4 places. 1, 2, 3, 4. So the lapping is in 4 places, and we have short extra length, which is short from here to here. So let us confirm the length of this short iron. So from here to here is 2.66, and the bend is 0.29. So our short iron is 2.66 and the bend is 2.69 and 0.29. So let us look at the section again. So we see we have top and bottom bar. So we have 3 number of Y16 at the bottom and 2 number of Y16 3 Y16 at the top and 2 Y16 at the bottom, with 2 number of Y16 to be this extra length, making the total number of the full length of Y16 on this grand beam is 5. 3 plus 2, we have 5, with extra length, which is 2. So if you want to take off for this one, mind you, know that this beam is in two places. That's why they said similar beams 1B to 21. So whenever we are measuring, we are going to measure it in two times. So let me look at the plugin for this ground beam. So it's going to be under flat foundation. So ground beam. So concrete ground beam, this is it. I'll click on it. So what's the thickness? As I said, is 0.3. 0.3, that is height. The width is 0.23. 0.23. So I click OK. So I click OK. I will measure this beam from here like this to this place. Mind you, we have in two places, so we have to measure it once again. Because in two places, that means in three places, we have to measure it 3 times. So I'm measuring two times. So I will drop the 2. So don't forget all this. We have total number of overlapping to be in 4 places on one iron. And we have Y16 to be 3 number of Y16 at the top and 2 number of Y16 at the bottom, with 2 number of Y16 to be extra length. And the lapping is 0.83, and total length of our extra length is 2.95, and the bend is 0.33. So I will click on this takeoff summary. So I will click on this takeoff summary. So we have 2 types of reinforcements, but in this case we don't have straight bar. We have straight bar with bend. So I will click on this straight bar with bend, double click on it, and input this parameter. So what's the diameter of the reinforcement? Is Y16. So the bar width of Y16 is 1.577. So number of bend. So what's the total number of bend we have? You know that total number of reinforcement we have inside this beam, we have it in 5. We have 5 numbers. We have 3 at the top and 2 at the bottom, making it 5. And one length of reinforcement is going to have 2 bend, 1 bend on one side and 1 bend on the other side. So if one length is having 2 bend, so how many bends are 5 lengths is going to have? So 5 lengths is going to have 10 bend. So we have to put 10 bend. So number of bend bar. So bar, you have total number of 5 number of bend bar. So what's the length? What's the length of our bend? We have to be 0.33. So 0.33. So number of extra length, the short length we measure here, we have it to be 2. So length of extra length, we measure it to be 2.76. 2.76 plus the bend, making 2.95. So number of lap. No, we have on one length, we have lapping to be in 4 places. That is on the 5 reinforcement on this ground on this beam, we are going to have 20 lapping. One length having 4 lapping, and 5 length is going to be having 20 lapping. So number of lapping going to be 20 lapping. So what's the length of our lap is 0.83 as scaled here to 0.83. Number of side cover is 2. So let's assume our cover is 0.025 and click OK. So quantity of our reinforcement Y16 on this beam has been generated to be 443.82. So what of our link on this beam? So let us, what's the size? So they use Y10 to be linked. So I will click on this again to know the quantity for our link on this ground beam. So diameter is 10, bar width for Y is 10, 0.6. So spacing, they use 250 to be spacing of this. So we input 0.25 to be spacing So number of side B. So I name this side to be side B. We have it in 2 places. So I name this side to be side A in 2 places. So side B. So our side B is 0.45, 0.45. Side A 0.23, 0.23. So hook, let's assume our hook is 0.15. So cover, assume to be 0.025, and number of cover, we have 2. And okay, so we've generated our quantities for Y10. So from work to this ground beam has been generated to be 21.10 square meters. That's that for ground beam. So the next item to consider, to be considered, so the next item to be considered so is column starter. So let us consider reinforcement to column starter. Reinforcement column starter. So I'm just trying to explain on how to use this tool. Not that you don't know how to measure, but how to use this particular plugin. So let me use this column type 1. Use this particular. So for column starter, so I'll click on this. So first of all, let me scale. What was the length of this column starter? So from here to here, you have it to be 2.32. So click here. So what is the size of the starter? We use Y25. So Y25. So Y25. So number of reinforcement they use 8 number. So 8. So diameter is 25. Number of column, we have 2 places. What's the length? As we scale 2.32. 2.32. So the bend doesn't have bend, so you have to leave that and click. Okay, the weight of our Y25 is Y25. So it's 3.85, 3.85. So that's all. I'll just click like this. So the quantities for this starter bar for column type 1 has been generated to be 142.9. So click OK. So what of link to this? Although we don't used to put link actually. So we leave that. So what, since we have covered all the structural elements, we have covered all the substructural elements. So let's go to superstructure. Let's go to superstructure. So let us use this plan. So first of all, let's check what's the height of this building from this section. So it's 3 meters height. So it's 3 meters height. But first of all, before you begin to calculate for, maybe you want to calculate for your block wall, you must first of all schedule your openings. What do I mean by schedule your openings? You have to categorize all your external openings on one side and those internal openings on the other side, for you to be able to to choose which opening is for external walls and which one is for internal walls. So before I begin to take off for this block work, I've already scheduled my openings. External openings has been scheduled, has been written down. Internal openings has been grouped on one side together. So what to do for block wall? So block wall, we all know that it's a superstructural element. So I click on this superstructure. It's under finishes. So mastery, I will click on this mastery and Planswift. So first of all, I want to consider my external block wall. This external block wall. So we know that according to this plan, our external block wall is 225, while all our internal block wall are 150 mm. So I'll click on this external block. So I'll now see 225 mm external block wall. So what's the width of our block? 0.23. So the wall height of the building 3.0, and click. So before we click, as I said earlier, that before you begin to take off for your block wall, you should have scheduled your openings so that you'll be able to deduct it directly. So I will click on this door. So what's the total number of door openings I have on my external wall? There's no door. So I'll click on window. There's window on our external wall, as we can see on the plan. There's windows and other openings. There's no door. So window 1 is 2.40 by 2.10, and we have it in 2 places. Window 2, we have 0.75 by 2.10, and we have it in 3 places. Window 3, we have 0.6 by 0.9. We have in 2 places. So that's that for. We have 3 windows on our external wall. Window 1, window 2, window 3. So what of other openings? Other openings are those openings other than windows or door. So we click on this other. So other openings, we have 2.50 by 2.1, and we have it in 1 place. Second opening, 0.9 by 2.1, and we have it in 1 places. So I'll click OK. So I begin to take off for my external wall. So I need to take off for my external wall. So taking off for my external wall. So my external wall, the openings has been deducted because I've already created in such a way that once I picked my tool here, the openings will be, template for opening will be displayed, and you put all my openings. So the total quantity of our block wall external is 55.2 square meter. So the openings has been generated. So having done this, I will click on this takeoff summary. So we've seen the block wall, the plastering has been generated too. All those area, window, reveal, and door has been generated with not exceeding 300 mm to be 52.9. So the remaining, so we are left with internal block wall. So I will double click on this internal block wall. So we put all the parameters. So it's 150 mm block wall, 150 mm internal block wall. So the width of our block wall is 0.15, and the wall height is 3.0. So do we have opening internally? Yes, we have openings. If you can see the plan, we have door 2 and door 1. So click on this door. So door 1 is 0.9 by 2.1, and we have it in 2 places. Door 2, we have 0.75 by 2.1, and we have it in 2 places. So that's all. I click OK and click on this mainboard ball to begin to measure for my internal wall. Start from here, come like this, stop here, start from here, stop here, stop here, here, stop here. So consider all my internal block wall. So I will drop the two. So as we can see, our internal block wall is 23.88. So internal plastering also has been generated to be 102.92. Total internal plastering. So the width of the door and window level 20.10. So we are done with block wall and plastering. Block wall, plastering. So the next item to consider is concrete in lintel. Concrete in lintel. So this is our lintel. Click on this lintel. So you see the magic of this one too. So all concrete formwork and reinforcement will be generated automatically, concurrently. So I'll click on this concrete lintel. So the extension, we have to input these variables. The extension, that is, what was the length we want to allow our lintel to enter our wall. So I want to assume 300 on one side and 300 on the other side, making 600, 0.60. So the thickness of our wall is 0.23 and the width 0.23. So I will click OK, and I'll be tracing all the openings. We have one opening, second opening, opening, opening here, all the openings. I have to trace them or to know the quantity of our concrete, reinforcement, and formwork to lintel. So opening here too. Opening here. Okay. So since okay, there's one opening too. So we've considered all our openings. So I will drop the two here. So let's see, concrete to 1.66, open lintel, formwork 18.12 square meter. So reinforcement. So our reinforcement, we are not giving schedule for our reinforcement in lintel, but normally we use Y12 for running length. So diameter to be 12. So number of reinforcements in meters, 4 number. So what the width? 0.88. Okay, so what of length? Style of Y10. So diameter of Y10, 10, weight of Y10, 0.616. So let's assume the spacing is 250. So number of cover is going to be 26. Cover 0.025. So side number, what's the number of our side? We have 4 sides of our link. We have 4 sides. So I will input the 4 number of side. So side A, what's the thickness of our block? 0.23, and the other side too, 0.23. So the lapping, let's assume our lap 0.15. That is hoop. I click OK. So the quantities have been generated too for our concrete in lintel. Everything has been generated. So the next item to be considered under superstructure is flooring, floor ties, floor ties, floor ties, the flooring. So flooring, I click on flooring. Although flooring, there's no shortcut, it's a straightforward thing, but I don't want us to see the magic of doing this, because once we take this tool for flooring under this QC plugins take-off templates, our skirting is going to be generated, cornice to our ceiling board is going to be generated too. So I click OK. So our flooring is going to be from here. Flooring. So flooring. So I drop the two. So now these are flooring, ceiling board internally that has been generated, cornice to our ceiling board has been generated. So ceiling board externally. Then that, so the next item is wall ties to our toilet. So wall ties to our toilet. Wall ties to our toilet. Okay, floor ties and bedding. So floor ties. The one that I did is flooring, normal flooring. So floor ties and bedding. I click on this. So click OK. So floor ties. So our floor ties too is going to be tile. Floor ties. So the tile we want to use for this area is different from the one we want to use for toilet. So I'm not going to consider this toilet. I'll use different type for it. So for this now, you can see our floor tiles quantities have been generated. So also skirting has been generated too. So the next time the wall ties to toilet. What ties to toilet? What's the height of our wall? Maybe I consider I want the ties to be full height of the wall of the building. So 3 meters. Okay. So this area is going to be ties. And click OK. So don't forget openings. We have openings, door 2 in 2 places, and will be 3 in 2 places. So I will double click on this word types. So door, we have door 2 to be 0.75 by 2 by 2.10, and we have in 2 places. We have dot 3. We have window 3, to be 0.60 by 0.90, and we have it in 2 places. So click OK. So it has been deducted. What tile has been generated? Floor tiles and bedding. So floor tiles to this toilet has been generated too. So that's that for finishes. So the next item to look at is roof. So let me. So first of all, what was the length of our roof? Let's scale it. What's it? So it has been scaled already actually. So the length of our roof is 9.55, and the width of our roof is 3.47. So let's look at it. So length of our building is 10 points. So length of our building is 10.01, and the width of our building, so the width of our building is 3.16. 3.16. So these are the parameters we are going to be needing when we are taking off for roof carcass. So, and total consists of wide for block internal block wall. Total internal block wall. The internal block wall. So let me look at the paper to know the total linear meter of our internal block wall. So if I want to take that, so the total linear is 10.27 for block wall, internal block wall, 10.27. Okay. So let's check the section of our roof. So this is the section of our roof. So let us scale. What is the length of our rafter? So from here to here. So length of our king post from here to here. So we are good to go. Having scaled all this, having known all our parameters, all parameters we'll be needing for this roof covering, for roof carcass and roof covering. So I will click on this king post. So our king post, so it's asks us what's the roof length as we got in. So roof length is 9.55. So what would be the spacing of king post is 1.2. Okay. So let's take the dimension of our king post is 0.63. So drop the 2 and go back to takeoff summary. So let us look. So for king post, so what of type B? So I will double click on type B. So roof width. So what is the roof width? We have it to be 3.47. Click OK. So our rafter, double click on rafter. So number of 4. We have the roof is 4 on one side. So number of 4 is going to be 1. And rafter length as we scale is 3.38. 3.38. Okay. So for line. So center to center of our corner is 900. Click OK. So backboard, all these quantities has been generated. Online, backboard, roof covering width, to the faces of fascia boards, 3.38. So roof trusses, we can do that by manual measurement. All our trusses, So that's all. So it has been multiplied by the number, the places in which they occur, that has been multiplied. So our own is just not more and multiplied by that. So I think we are clear with roof covering again. So since we have covered everything concerning this plugins, okay, remaining noggins, roof noggins. So noggins, I'll click on this internal noggins. So for noggins, what's the building length? Our building length, as we seen earlier, is 10.01. So what's the width of our building? The width of our building is 3.16. So what total quantity of our internal block? The reason why I consider total quantity of internal block, you know that whenever we are laying our noggins, all the area in which internal block wall are covered are going to be deducted. So that's why I take all the total linear meter of our internal block wall to be deducted. So it's going to total linear meter of our block wall is 10.27 for internal wall. So block width for internal is 0.15. And center to center of the noggins is 600. And click OK. So just click like this. So it has been generated. You go grab the two, go to takeoffs summary. So this is the total quantity of our nuggets to be 100.32 meters nuggets will be needed for this. So since we've covered all this, we've done justice to these two. So in case you are interested in having these two, you can contact me via WhatsApp or my email. So I'll be dropping my WhatsApp number and email address for whoever that is interested in having this QC quantity of templates. The essence of this QC quantity takeoff templates is for time management. You know, we are all working and want to be time conscious. We don't want to use a whole day in taking off for a simple and one project. So the essence of this plugin is just for us to estimate our measurements and improve in our accuracy, the accuracy of our quantities. So if you are interested in having these QC plugins, you can contact me via WhatsApp or through my mail address. So we talk on how you can get it. So my next lecture is going to be based on how to install this plugin into our various Planswift. So I would like to stop here. So whoever that is interested can contact me. I can have a personal tutorial with you on how to use this plugin. So thank you for listening.